Hello, this video is on section 8.2, which is titled Multiplying and Factoring. And there's two targets for this one. The first one is to multiply a monomial by a polynomial, and the second is to factor a monomial from a polynomial. So just looking at the difference between the two targets, one is a complete opposite or reverse process from the other, where you're multiplying things together or you're factoring them out to a more simplified expression. So when you're multiplying a monomial into a polynomial, you can take your distributive property that you already know and apply that to the exact same thing. So just a really easy example is if you have the monomial 2x multiplied to the polynomial 3x plus 1. Well, you take your entire term 2x and multiply it by the 3x, and then you also take it and multiply it by the 1. So 2x times 3x gives you 6x squared, and then 2x times 1 gives you a positive 2x. Now these are not like terms because one is an x squared and one is an x, and you can't combine them together. So that's when you multiply them together to be the simplified version with that polynomial. Now some of the expressions are going to be a little bit longer, but in this section only, you're only going to be looking at terms that have a monomial out in front of your parentheses. We'll get into binomials later, but the only thing you'll see is a monomial out in front. Now going into factoring a monomial from a polynomial, again, it's the exact opposite or reverse process of distribution, but what you do need to know is to learn how to find the greatest common factor, or the GCF, of each of the terms inside your polynomial. So if your first one is 4x to the fifth, what you need to do is to find all of the prime factors of all these numbers. So the factors of 4 are 2 times 2, and then you have 5x's, or x times itself 5 times. Okay, that's the prime factorization of 4x to the fifth. You can't factor any of those terms out anymore. Then 24x cubed. The prime factors of 24, you have 12 and 2, and then you have 4 and 3, and then 2 and 2. So you have 3 2's times a 3. 2 times 2 times 2 times 3, and then you have 3 x's times itself. That's the prime factorization. All of these numbers cannot be factored anymore. And this is what here is called a factor tree. Some of you should be familiar with it from AG1 on how to find factors. But this is a way you can find all the prime factors of any number or any term. It's just all the numbers that are on the bottom or that don't have anything else spreading out from underneath it. Then the last one is 8x. The prime factors of this are 2 times 2 times 2 times x. So again, the factors are 4 and 2, and then you can factor out 4 again twice. So when you have all the prime factors of all these terms, what you need to do is to find everything that is seen in all three terms. So there is a 2 in all of these, and there is in fact a second 2 in all of these terms. You could say that these two have a third 2, but this one does not have another 2 present, so you can't circle these as greatest common factors of those. So the only thing that's in common with all of them is 2 and 2, and then when you look at the number of x's, this one has 1, that one has at least 1, and that one has at least 1. So there's nothing else that's in common left over from this term that you see in all of the others, or same thing with this one. There's no more left in this that you don't see in all of these. So the prime factors, or the greatest common factor of this, is 2 times 2 times x, or 4x. And this is the greatest common factor, or what you're going to factor out of all the terms in here. So when you factor it out, you pull it out to the side, and you look at what happens when you divide each term by your 4x. So 4x to the fifth divided by 4x leaves you with x to the 4th power. 4 divided by 4 is 1, or there's an understood 1 multiplied out there. And when you have 5 x's and you take away 1, there are 4 x's left, which is exactly what's left here after you take out the greatest common factors. Now the same thing can happen with the negative 24x to the third. 24 divided by 4 gives you 6, or 2 times 3, which are what these factors are right here. And it's negative because this negative is shown in the example problem above. Now you start out with 3 x's, you take out 1 x, so that means there's 2 x's left, or looking at the greatest common factorizations, you have 2x's left, so x squared. Then the 8x, 8 divided by 4 is 2, or the only number left in here is 2, and you took out the x by doing 8x divided by 4x, so all that's left is a plus 2. So if you don't necessarily see the division that I was talking about, where you have 4x to the 5th divided by 4x and you're left with 4x's, just take a look at the greatest common factorizations. We got x to the 4th because the only numbers circled are x times itself 4 times. Then 2 times 3 is the 6, since it's the negative, and there's 2x's left, so it's x squared, and then the only thing that's left for this last one is 2. I think multiplying you guys should be okay with, but greatest common factor will take a lot of practice, and if you absolutely have to, I strongly recommend you writing out all of this and circling what's in common to find your greatest common factor that's pulled out in front. Then the only thing that's not circled goes in here in the middle. Alright, that's all. Thank you very much.